Okay, let's get this show on the road. So thank you all for joining us. This is going to be a webinar on the Peel 3 scanning system and how you can use it to get started with reverse engineering. Before I dive into the webinar, just a quick housekeeping note. If any of you have questions at any time, there's a little questions field in the GoToWebinar window. It's just above the chat window, and you can use that to send me questions. Be sure to use that, not the chat field, because that way everyone can see all the questions being asked, and I will try to get to them as soon as I can. But with that out of the way, welcome. So my name is Judah Sher. I'm an engineer here at GoEngineer. I have my degree in industrial design. I've done a little bit of everything over the years. I like camping. And I really love 3D scanning. It's actually my favorite part of this job. So I'm really excited to be able to share the Peel 3 system with you. So what is the Peel 3? The Peel 3 is an affordable turnkey professional grade 3D scanning solution. So it's priced very very low for what it is. It's a very powerful 3D scanning system. It's accurate within 0.004 of an inch, which is ridiculous for something like this. And it's also designed to be very intuitive and easy to use. So if you've never done any 3D scanning before and you're looking to bring it on board, it's a really great option to get you started in that. So, but why might you want to bring 3D scanning on board? So there are three main advantages of using a 3D scanner versus traditional tools like micrometers and calipers and, well, measuring tape. And the first one is speed. So with a caliper or a micrometer, you're taking one measurement at a time. The Peel 3 is measuring 1.25 million points every second. And so that, to give you an idea of what that means, you can scan an area, a square foot, in about 7.5 seconds. So, and when you scan that square foot, you have this very high dense mesh replicating what it is that you're scanning. Now, in terms of accuracy, I mentioned it's accurate to within 4 thou. And if you have larger measurements, of course, like any tool, the larger you get, you do lose a little bit of accuracy. So you do lose an additional 3 thou per foot. But for a lot of things, that's going to be fine. You're always going to be probably within a 1/16 of an inch, even with some of those longest measurements. And now where these tools really shine are things that you simply can't measure with traditional tools. So for example, if you have some sort of complex curvature, like say injection molding tooling, and you need to be able to check to see, well, how accurately was that tooling made? You can't really do that with just traditional hand tools. You need some way to compare these three-dimensional shapes. And that's what a 3D scanner can do for you. You can bring in the CAD and compare it to the mesh with some additional tools. And you can also scan that complex surface and create the CAD. That's what reverse engineering is all about, after all. So, and it can do this with very complex organic shapes, or even if shapes are damaged, you can undo that damage with some of the reverse engineering tools that I'm going to show you. So, without further ado, I'm not a huge fan of PowerPoint. I just like to show you stuff. So I'm going to go ahead and switch over to a video I took of some scanning. So in the main window here, this is the Peel 3 interface. And over in the corner, this is a video that I took while doing the screen recording, so you can see what's going on. So in this video, I'm scanning my cordless drill here with the Peel 3. It's sitting there on that turntable. And you'll get to see that process. So what we have on the screen right now is the very first screen when you start a new file in the Peel scanning software. And first thing you do is just tell the system a little bit about what you're trying to do. How large is the object? What kind of detail are you trying to pick up? What kind of output you're looking for, whether you want something that's cleaned up a little bit with some nice fine details, or whether you just want something very fast, and whether or not you care about picking up color. So the Peel 3 is capable of scanning things in full color, and they look really great. Now, if you want to get into the weeds in terms of exactly specifying what all these get into, you actually have this advanced control where you can specify things like the resolution of the mesh that's being generated and the scanning area. And this is for if you're scanning very small objects, you can have the scanner focus just on that and not have to clean up a larger area. So it can be very helpful there. So go ahead and start this video. And so I'm just going to click on that next button and we'll start the scanning process. So I'm picking up the scanner, pointing it at the drill, hitting the play button to get started. And you'll notice it'll start picking up a lot more data here in a second. And what that is, I've changed the shutter on the scanner. So it has two settings. One's better for light colored objects, another for darker colored objects like most of this drill. And so that way you can optimize it for picking up different kinds of shapes more easily. I'm going to speed this up a little bit so we're not staring at scanning all day. But you can see on the screen we have a few different colors. We have blue, and that tells us that those areas are too far from the scanner. If I get too close, you'll see a few spots where it becomes red. Now, and that tells us we're just too close. Now, I've stopped scanning. I'm looking around and seeing if there are any areas I need to scan again. And I notice this area on the chuck. So that's fine. I can just bring the scanner back, turn it back on, and add that in. I don't need to do another scan. I don't need to start over. I can just go back and add more data. And so it's really easy to work with. You don't need to worry about making a lot of mistakes. So I'm just doing another check again and saying what else I need to pick up. There's some areas right here. I think I'm going to zoom in. Yeah, so around the battery area. So I'm going to scan that area a little bit more, just get a little bit more detail. Make sure I have a nice mesh. So now that I've done this scan, I'm going to give it another spin around, make sure there's nothing else I want to pick up. Now, I'm also going to, so now I'm going to clean up the scan. So I'm getting rid of the turntable there. It's called a background deletion. Then I'm going to use this tool to select just the drill and get rid of all these extra things like my hand and other little things that got in the way during scanning. So you just click on what you want to keep, hit that keep only button, and your scan is nice and clean. Now, because of some areas that I didn't quite get, I'm going to do a second scan. So you see I'm putting the drill on its side here so I can get some of those bits on the underside of the chuck and other parts and add that to my scan. Now, I'm propping it up with a little block there, and I want to make sure it doesn't wobble on me during scanning because that can cause some issues with acquiring good data. So there we are. I'm just going to start another scan here. And works just the same. I'm pointing it at the drill and spinning that table around. And so there you can see some of the red color come in when I get too close. And having that live feedback is really helpful. You don't need to worry about immediately being excellent at 3D scanning. It holds your hand a little bit. Now you'll notice sometimes it stops moving. And what's happening there is the scanner has lost tracking of the object. It's now no longer sure where the scanner is. And so I'm just going to pause here for a sec. So it's going to avoid capturing bad data that way. If it's not sure where it is, then it'll just stop acquiring. Now, because it's so good at not acquiring bad data, I'm actually going to manually introduce some bad data. I'm going to reach in and touch the drill while I'm scanning so I can have something bad to show you how you can recover from that. So you can see here, I have a couple fingers in the scan, and those would be annoying to delete out manually. So instead, I'm going to use a nice feature called this rewind feature. And I have the slider up here, and I can specify how far back in time I want to go. And then I can just delete the last few seconds of scanning and not have to worry about trying to get rid of those fingers later on. And so that's really helpful. Anytime you for whatever reasons, get some bad data, you can easily recover from that. You don't have to start all over. So that's a huge help. All right, that looks very good. I'm going to go forward, do another background removal. This time, I'm defining it by just selecting 3 of these targets. Then again, deleting everything that I don't want. One other thing I'll mention about those targets. So I was scanning this on a turntable with targets. those are not actually necessary. They are helpful in keeping scans well aligned. You're less likely to get some weird data that way. But you can also take this scanner and scan anything with enough detail without targets. It's not a problem. So those are not, strictly speaking, necessary, because I know some people are concerned about that. So here's how we manually get rid of something we don't want, like this block. And I'm just going to draw a little box around it. I have select through turned on. So that is selected. I'll just delete that. And now that's no longer in my scan. So we can go to the next step, and you'll notice it has automatically aligned those two scans relative to each other. And that's if you do a good job of scanning two things where there's a lot of overlap in the two scans, you don't usually need to worry about manually aligning the two scans. The software is pretty intelligent, and it just figures that out for you, which I find really, really helpful. Now, if the software can't quite figure out how two scans go together, it just puts you into a workflow where it has both scans on the screen, and you can rotate them individually and pick 3 points in common on both. And as long as they're kind of in the neighborhood, then it can get you the rest of the way into a really nice alignment like what we see here. But when you see that speckled look to the surface, you know the two scans have been well aligned. So the next step is the align step. However, you'll notice as soon as we start the align step, speed this up a little bit, suddenly the drill looks a lot cleaner. And that's because between the merge and the align step is the finalize step. It's sort of in the background. And that's what's taking sort of a rough preview, which is what we've been looking at up till now, and does some final calculation to get you this really nice clean mesh with all of this detail. And let's say you see this mesh and you realize that it doesn't have quite the resolution that you wanted to pick up some of the finer details, you can actually go back to the parameters, choose a higher resolution, and then skip forward to this align step, and it will do some recalculations and give you that higher resolution mesh without having to rescan. And that's because the scanning data behind the scenes is always at its full resolution capability. So you don't need to worry about having to rescan if you need more detail later, which is a beautiful feature. Now, this scan, of course, is about aligning the shape to the coordinate system. It does a pretty good job of just centering your data, but we can also manually specify where the part is relative to our XYZ coordinate system. So I'm going to map the bottom plane to the bottom of the drill here. And then let's see, so we can also do various constraints with axes. I'm going to try to map the y-axis to the drill chuck. When I do that, it actually puts the origin way back there. So I decided not to do that. So I'll cancel out of that. And instead, we'll just use the side of the battery here as another one of our construction planes. And that's just going to be simpler. Now you'll notice these rings and arrows are getting grayed out. Those are our 6 degrees of freedom. So we've constrained in 5 of those 6, and now it's just this the Y direction that things aren't fully constrained in, but it's good enough for our purposes. So that's a full scan. I did speed up a few parts of it, but not really much. So now I'm going to go fully live, no longer recording, and we're going to switch to the Peel software itself. So you notice back in the recording, we have the option to switch to the peel.cad environment, and that's what this is. So the mesh that we got from that scan is now here in peel.cad. So, of course, we could do all sorts of things to reverse engineer this drill, and we can do amazing stuff. Actually, I'm going to start launching SolidWorks in the background because we can actually transfer entities directly into SolidWorks with this button. It's not exclusive to SolidWorks. It'll also work with Inventor, Fusion 360, and Solid Edge. But it's you'll see how nice that feature is. Now, so we can start doing reverse engineering in a few different ways. I'm actually going to start by moving my alignment, because one thing that I can do in here that I can't do just in the scanning environment is do things like create mesh symmetry planes. So there's no piece of geometry that I can map a plane to that'll split this thing right down the middle. But if I tell it I'm looking for a symmetry plane, and then I just click and drag a line roughly down the plane of symmetry, you notice that instantly it creates this white plane that is a perfect little plane of symmetry. Even though there are some asymmetrical details on the drill, it is able to figure it out and give us a true symmetry plane. Let's see, so that's nice. I'm going to make another plane on the bottom of the drill battery. That looks good. And let's see, I'm also going to map a cylinder to the chuck like I tried to before. But this time, now see how the selection has bled into this conical part. And so the cylinder's a little off. What we can do is we can make the selection tolerance a little pickier. And if I keep decreasing this, eventually so it's a lot more picky when it's trying to find a cylinder. So now it's just doing the truly cylindrical part of that chuck. Great. Let's see, are there any other entities I want to map on here? I think those are probably going to be good. Well, let's fit a plane to the back of the drill too. Might come in handy. And for here, I'm going to actually increase the selection tolerance. There we go. Just something that's facing roughly the right way. So what we can do now is create a new alignment. And the way in which you choose these entities prioritizes them. I won't get into the details, but it means you have a lot of flexibility in terms of how to orient things and how they come into your CAD environment. So I'm going to call this the YZ plane. Let's see, I'm going to rotate my view so I'm doing Y up. And I can now manually move things around if I want. But I now want to get that second plane. We're going to snap that to the XZ plane. And it's facing the wrong way, so I can just flip that, not a problem. And so now we've again constrained 5 of the 6 degrees of freedom. And what I'll do here is I'll use that last plane. And I'll call that the only planes left, XY. Now you'll notice this plane is very much not perpendicular to my other planes. But that isn't a big deal with the software. What it's doing instead of warping the other planes is it's extending that plane down and trying to get the coordinate system to intersect that plane as best it can without violating any of the other constraints. So you really have a nice degree of control there. Okay, so now it's nice and aligned, and we can start to do some reverse engineering. So on the basic level, we have, of course, simple planes that I've already made. And if I want to, so for example, if I wanted to have that plane on the back of the drill, I can just select that plane, click Transfer to SolidWorks. And what it'll do, I just realized, yeah, there we go. So here's an empty part file, and it's created that plane. I mean, nothing fancy, but notice it is a construction plane. It doesn't come in as a surface you need to turn into a construction plane. It is exactly what it needs to be. And it gets really cool when we transfer in entities like cylinders. So when I first got into the software, I'd expect, it just comes in as a solid body. No, what it does is it creates a plane, creates a circle sketch on that plane, and extrudes that circle to the right height for the cylinder, and finally creates a 3D sketch for the axis of the cylinder. So all of that comes in immediately on the when you transfer an entity like that. So it's immediately a parametric feature, which is really nice. Now, how I'd actually go about reverse engineering this, I have a few different options depending on what my goals are. So let's say I wanted to recreate this grip. One way I might do that is with a lofting operation. So I can do that by making a bunch of cross sections. So I'll use this cross section tool and we'll do multiple cross sections. For my initial plane, I'll choose my XZ plane. And then I can choose an initial offset. And then let's start increasing. Oh, I need to go in the other direction. Oh, sorry, flip that. There we go. And I can specify the spacing. So let's say every 0.4 inches, I'll have a new sketch. Oh no, there we go. And let's maybe do, or actually let's do half an inch. And we'll do maybe 6 planes. Start there. Oh, gotta flip that again. There we are. Wonderful. And you can see how these cross sections start to stack up. I'll just keep them brief just for the sake of time here. And I have options to output those as splines or as polylines. Splines are usually the most helpful. And I can specify how accurate those splines are by determining their maximum deviation there. So once I have those, I can go out of this tool. I'm going to select all these cross sections at once. Click that Transfer to SolidWorks button again. Give that just a little bit to work its magic. And here we are. So there we are. So here I have all of those cross sections. And what I would do is I'd go in and make perfectly symmetrical sketches on all of those planes based off of the cross sections that come in. And that way I can then loft all those together and recreate that grip. Now that's one way to do it. The nice thing about doing it that way is that a loft feature is fully parametric, so I can tweak the shape of the grip if I want. Another way to do this, if we don't need it truly parametric, we just want to say, create a fixture to hold this grip, we can do something else that's really cool. But before that, so if I want a grip, or if I want to make a fixture, I don't really care about these screw holes. If I have a jig that tries to fit into those, that might cause some problems. So let's go ahead and get rid of these features. Now there's a wonderful button for this where I'm just going to go in, use this little paint selection tool, select that area that has the detail I want to get rid of, and here's this defeature button. I click that, and oh, looks like I might have not had everything selected. When you have a little dimple left, that's usually what that means. But that looks pretty good. Great. Defeature. Huh. The joy of live demos. Let's try grabbing that. We're going to expand. That should get rid of everything. There we go. There's a little triangle that wasn't getting defeatured. But you can see that not only did it delete that hole, it matched the curvature of the surrounding mesh, so it's like it was never there. I'm going to do that again with this hole here. Make sure I get everything. Expand my selection a little bit. Shrink it back down. Defeature. Boom. Gone. Now you can also do things like there's a sandpaper tool, or if we just wanted to smooth something out a little bit, I can expand the size of my piece of sandpaper and just soften out that detail, which is nice. Yeah, maybe we'll do that over here as well. So you have all sorts of options. Now, of course, sometimes there are going to be little holes in your scan. We have tools for that too. So there's the fill hole command, which can be as simple as click on the boundary of the hole and it'll fill it. Or if you want to be a little more careful about how you do things, you can fill parts of holes. So I'm going to fill from here to here, fill just that part. You can even do bridging, where if we could split this hole into 2 holes by going from this part. Oh, looks like let's reset the selection. There we go, from there to there, and from there to there, and it'll bridge just that part. So you have all sorts of options. You can also fill multiple holes at once. So down here we have apparently 32 holes, and we can step through those, and it'll show us where all those holes are. And they're ordered in order of bound size, roughly. So what we can do is say, all right, let's go ahead and just quickly fill the 21 smallest ones. And we can do that. We can also, there's this button called the watertight remesh function. And what that can do is it'll automatically get rid of all of the holes. I'm not going to do that now because it can take a little bit of time to calculate, but it's very much an easy button to get a scan ready for 3D printing, for example. Okay, but this is about reverse engineering. So let me show you the really fun tool that I have here. That's the auto surface tool. Now, you could do this for the entire shape if you want. But I'm just going to do it for one small part here. Let me get around the sides. Actually, let's just get all the way around. There we go. And if I click this auto surface button, I'm going to turn the detail down just for the sake of time, but it'll still be very detailed. It's going to create what's called a NURBS B-spline patch network, which is just a fancy way of saying it's a surface body that you can then bring into your CAD software as a surface. So since it's a true surface body, it's no longer just a mesh. You can do things like extrude up to it and create soft jaws or different kinds of fixtures. So that way you don't need to go, even if it's a complicated shape, but you just want to be able to grip it, you can bring it into your CAD software as one of those auto surfaces and then do things like trim it, extrude up to it, everything like that. So does anyone have any questions or things that they'd like to see about the peel? See if I can expand my my question bar here. So it looks like there's a question about the turntable. So we sell, it's a very nice turntable with a heavy duty bearing, so you can put very heavy parts on it. It'll still spin smoothly. It just comes in a flat black color, and if you want, you can just apply your targeting stickers to it, and it just makes for a really easy scanning setup. Let's see, when scanning, can you add targets directly to the part? Yes, absolutely. For smaller parts, I tend to do just the turntable. That way I can just reuse the same targets over and over again, which is really nice. But for larger objects, you can absolutely put the targets directly on the object you're trying to scan. And this can be a big help when you're trying to scan something very large that doesn't have a lot of detail. Because if it doesn't have a lot of physical detail, the scanner can have a hard time doing keeping track of where it is. So how big of a space can you use this on? Really, so it's designed to scan objects up to 10 feet. Now, you can use it to scan things bigger than that, but the accuracy is going to go down rather quickly from there. Now, depending on what you're scanning, that might not be a big issue. So if you're trying to scan a whole car because you want to put a model of it in your video game, it's fine. You don't care if it's a little inaccurate, if the dimensions aren't perfect. But if you're trying to reverse engineer something, it's really only good for objects of about 10 feet or so. That's what it's optimized for. Now, we have just a few more minutes, something else I wanted to show you. So I mentioned that it can do color. Let me show you what that looks like. So this is a different drill. Let's see, I'm not going to save my work, that's fine. But this one I scanned with color on, and the quality of the color on this object is really surprising. So open it up in peel.cad, and here it is. So if I zoom in, I can actually read some of this text here, which is really nice. But if any of you have done any video game editing, this is all ready to put in a video game. So here you can even read the text down there. And it takes just the same amount of time to scan with color as without, It does slow your computer down a little bit more because there's a little bit more calculations, but it does an amazing job. Any other questions I can answer for people before we call this a day? I've appreciated all the questions. These are great questions. If there's anything in specific you'd like to see that I haven't shown you before, let me know. We'll see if I can work it in. Happy to do that. Ooh, what laptop hardware? I don't know the specifications off the top of my head, but we can definitely send those out to you after the webinar. There's a nice little brochure with all the specifications of the scanner itself, and those also detail what hardware is recommended. Can you do a quick example of extruding to the handle in SOLIDWORKS? Absolutely. So here is my handle. I'm going to make a sketch on my right plane, and we'll just do a quick random shape here. It's within the bounds of that surface. Great. Exit the sketch. Extrude a boss base. We're going to start with an offset because we're in the middle of it right now. So let's do, I think 2 inches should do it. Yep. And then up to surface. Nope. Nope. Hold on. Up to surface. Here we go. There's my surface. Oh, it's not wanting to do it. That's how you know it's a live demo when things don't work right the first time. So let me just make sure I have a fully, I'm going to hide these two. Oh, didn't work. That's fine. Edit the sketch. All right, it is fully closed. Good. Maybe try making this a little bit smaller. There might be some sort of imperfection that I'm not seeing immediately. That should be fine. Try this once more. All right. Offset 2 inches or whatever that is. Sure. Direction up to surface. There we go. Yeah, not sure why that didn't work at first. So now if I hide this surface, you can see that it's basically recreated on this side of the extrusion. So it'll fit to that handle just perfectly. Great question. Let's see, is there anything else anyone would like to see? Well, if any of you have any questions regarding the PL3, please let us know. We can set up virtual demos that are tailored to your needs. You can send us a part and we'll scan it for you live and reverse engineer whatever you need and show how this software can help you out in all sorts of workflows, from quality control to reverse engineering old tooling or welding fixtures, all sorts of things. So I hope you found this informative. Thank you all for joining. And again, if you have any questions, feel free to get in touch. Have a great day.